is homework 4, part B, part 1. A canal has a trapezoidal cross section such that the width at the water level in meters is WT equals 4 plus D over 4, where D is the depth of the water in meters. Derive an expression for the hydraulic radius as a function of depth. Okay, so here we have our canal with its depth D. And this is the wetted base area. So first, we have this equation. Almost F L over D times V squared over 2. Okay. Then we have delta P over rho plus Q delta Z plus V2 squared minus V1 squared all over 2. And then that is equal to negative this. Okay, then we have G is equal to Z Z1 minus Z2. Then we have this. So F L D Okay, so now we can start finding the hydraulic radius. So that the hydraulic radius is going to be equal to the area over the wetted perimeter. And this is going to be equal to the wetted base. Make that be a little bigger. Wetted base plus D over 8 times D. And this is going to be all over D square root of 65 over 4 plus wetted base. I can continue to find this. So this is going to equal to pi r squared over 2 pi r. So we can cross out pi, get rid of this r, get rid of one of these. So we're left with r over 2, and that is equal to d over 4. So that's how you do part 1. This is homework 4, part B, part 2. Over a length of 200 meters, the canal's elevation drops by 10 meters. Using Churchill's equation for the Darcy friction factor, use Excel solver to determine the depth of water in the canal at a flow rate of 5 meters cubed per second. All right, so I already have the Excel set up a little bit. So the bottom width of the canal is going to be 4. So we have that. We're solving for the D, so we're not going to put in anything there. This is going to be equal to the one equation we got here, There's going to be this wetted base plus d over 8 equation. So we're going to do equals WB dot, and we'll name that later. That's going to be plus d dot over 8. Okay. Checking equation again. And all that is going to be times d dot. And then all of that divided by d times SQRT. SQRT 65 all over 4. And then plus wetted base plus WB dot, we're gonna add all of that is in parentheses. Oh, not that. Right. Well, okay. We'll just read that. Okay. All right. WB dot plus D dot over 8 times D dot. All that is so parentheses then D dot times SQRT 65 divided by 4 plus WB dot. And then we hit this, and then we'll hit enter. One or more circular references. Well, oh, we want a different D dot there. Well, let me do that. Okay, I think we need to name this first. So we'll name these. If I can remember how to do that. Name manager. Something like that. Oh, can I right click this maybe? Define name. I want both of them. I'm going to do both of them. Or hit Control Shift F3. Left column. Is there already a D dot? Yes. Okay. So we got that. I think it's still pulling from here. Yep. I'm gonna say this is 1. Okay, so we're gonna rename this to renewally. Make this as key flow. This is just going to be some Okay, so this is going to be equal to B12 minus D12. So this is going to be our target flow rate. So our target flow rate is 5. So that's our flow rate there. And this is going to be the sum of these two. Oh, the other sum. Yeah. So we want this to be 0 while changing the velocity and the depth of the water, and this will get 0. So we're gonna do solver. So we're going to min the square by changing. So we click it. All right, so we want to change the depth and the Q. Oh. Okay, that should do it. Ooh, that's not it. And the first character is an equal sign or minus sign. Excel thinks it's a formula. It probably is a formula. So I made some adjustments to our equation. I forgot the 4 times here initially. I'm actually coming back from this a day late. I met up with you, Carlos. We went over this, and this is what I ended up with when I think I fixed everything. About 2. So yeah.